So far, we have discussed three in fact, numeric methods for finding the roots of a nonlinear equation: bisection method, fixed point method, and Newton method. But in Newton method, that was the best technique to finding the zeros of a nonlinear equation. You saw that we have to generate a sequence like this. Yeah, it's here. This, okay? Xn equal to xn minus 1 minus f of xn minus 1 over f prime divided by f prime xn minus 1. And we start with, for example, an x0 equal to, for example, 0. We compute f x0 and f prime x0, and we compute the right hand side, and we get x1, for example, something. And we continue in this way. But there is a problem here, and that is we need f prime of a function at xn minus 1. So in fact, we have to compute f prime. And this is a problem, and it needs some extra cost for our algorithm. Okay? To avoid this problem, we need a new technique that we call it the secant method. The secant method is not as fast as the Newton method, but it's better than fixed point and bisection methods. The concepts of the secant method is that in the sequence xn equal to xn minus 1 minus f of xn minus 1 over f prime xn minus 1. Okay, here we use, instead of f prime of xn minus 1, as the definition of the derivative of a function at point xn minus 1. This is the definition: f prime of xn minus 1 equal to limit x to xn minus 1 f of x minus f of xn minus 1 over x minus xn minus 1. If we get x equal to xn minus 2, okay, we can put xn minus 2 here, xn minus 2, and we ignore limit, and we change the equality to approximate almost equal. Okay, so we can put f prime xn minus 1 almost equal to f xn minus 2 minus f xn minus 1 over xn minus 2 minus xn minus 1. And we want to compute the xn from xn minus 1. We put, instead of f prime xn minus 1, this item. In fact, we put this item here instead of f prime of xn minus 1. Now, something like this. Okay? So, what's the meaning of this algorithm? Consider, in this picture, we start with P0, and this is f of P0. So here we have P0 and f of P0. Okay? When we find P1 from P0 with this equation, P1 equal to P0 minus f of P0 over f prime of P0. Okay, and we find this P1. So if we continue this line until it intersects the curve, and we call it P1 and f of P1. Now if we write the equation that path from P0 and f of P0 and P1 and f of P1, we get this line. Okay, this line. The intersection of this line with the x-axis, we call it P2, and this is P2 and f of P2, and we continue exactly in the same way. In fact, we draw a line pass from P2 and f of P2, P1 and f of P1, and we continue in this way until it converges to P. Okay, but let me show you the story of the secant method. Unfortunately, my computer is slow. Now, consider that if we use here in xn equal to xn minus 1 minus fx minus 1 over f prime xn minus 1, we put instead of f prime xn minus 1 this term. Okay, this term. And we get xn equal to xn minus 1 minus f of xn minus 1 over this term. So if we multiply this term, here we get a new equation here, and we can simplify also this equation. Let me show you in the next slide. Here, if you, for example, here consider xn minus 1 minus, or let me show you in a free page. Let me do it here. Very slow. I am bored. Okay, we get something like this. Now, let me multiply xn minus 1 by the denominator of this 1. So I can get xn minus 1 f xn minus 2 minus xn minus 1 f xn minus 1 minus, and multiply this one in both. So we can get xn minus 2 f xn minus 1 and plus xn minus 1 f xn minus 1 over f xn minus 2 minus f xn minus 1. Okay, so we can delete these two items, and just we get xn minus 1 f of xn minus 2 minus xn minus 2 f of xn minus 1 over f xn minus 2 minus f xn minus 1. And we can use this one as new xn. Okay, so let me back here. In this way, if we continue, we can get from n equal, if we put n equal to 2, so x2 will be compute with x0 and x1. Let me call it p0 and p1, so we can get this picture. Okay, so we start with p0 and p1 and as the initial values, and we get the new point. The new point p2 will be here. In fact, here I use this equality to finding the new point. The new point p2, for example, p2 is let me clear this. This is not true. So here, in fact, we use this one, p2 equal to p 1 minus this equation fp1 times fp1 times p2 minus p1 over fp2 minus fp1. p2 will be here. In fact, p2 is the intersection of the line and the x-axis. And we start this process with p2 and p1 to get the new point. This is p3. And we continue in the same way until we get the new points and so on. This is the second method. The second method has a very simple algorithm. It's like this. We start with two starting points, Q0 and Q1, for example, P0 and P1 as a two starting point, a tolerance, for example, 0.0001, and the maximum number of iteration. So we start with Q0 equal to f of P0 and Q1 equal to f of P1, and we continue steps 3 to 6. In fact, this one, this one, this one, this one, this one, and this one. When we apply these steps, we get a new point for P0 and Q0, and we continue all of these steps until we arrive to the favorite tolerance. This is the second method, and it's not difficult to implement. It's very, very easy. Let me show you the MATLAB program for second method, and we compare it with bisection method and Newton method. For example, here, for the fixed point method, let me consider this equation. Let me consider this equation. 3x e to power of x minus 1. We want to solve this equation with this error term. Okay? So let me set all to the same error. Oh, sorry. Where is the error? Let me see. Toll. Where is toll? Yeah, it's here. Copy. And let me paste it here. Okay. Let me save it. Now, let me start with fixed point method for the same equation and same the tolerance. Okay? So, if I implement the fixed point method, I will get the solution in about 12 iteration, 0.257628. This is fixed point. Okay? This is fixed point. Now, let me implement the Newton method. The Newton method. It is here. Let me implement it. I get the same solution in just 5 iterations. Okay? So, Newton, 11 iterations, fixed point, 11 iterations, and Newton, 5 iterations. Now, let me apply the second method here. This is the second method, the code of second method. It's very simple. And let me run it. We get exactly the same solution in 8 iterations. So, easily you can see that the second method is better than fixed point with 11 iterations, and it's worse than the Newton method with 5 iterations. So, in fact, the second method is something between fixed point and Newton methods. Okay, this is very good method when we don't want to compute the derivative of function f at some points. So now let me compare some methods with together. I forget about the regular falsy or the false position technique because it's not very important and maybe we don't use it too much. Now let me see. In the bisection method, in fact this is a linear convergence and it's very slow, okay? But the secant method, it's slower than Newton, but faster than maybe fixed point. And Newton method, it's in fact quadratic. I will talk about the quadratic, linear, and semi-linear, and something like this. This is the fastest method for the convergence of the methods. Okay? Now, let me compare it about the, for example, iterations. This is the technique of bisection method. This is a summary, in fact. This is secant method, and this is Newton method. We talk about it. Now, about the cost of the, in fact, numerical method. The cost of bisection is cheapest, because we just do some mathematical operation like plus, minus, and division and multiplication or something like this. This is cheap, okay? But Newton method is expensive because we need f prime of x. But secant method is cheaper than Newton, but a little more expensive than bisection method. Okay? And finally, let me stop here and I continue about the error analysis in the next lecture. Just I have to say that if you want to access to lecture notes in some part of this video, you can find a link in the above right of the video. If you click on the video, you can access to the lecture note, this lecture note, and I will receive an email from you and I allow you to download the lecture notes. Please subscribe my YouTube channel and introduce my channel to other students and your friends, and please support me by clicking on the YouTube videos. Thank you very much.